All right, everybody. We are going to start off our lesson on scatterplots and line of best fit. In class, you'll get to do an activity where you get to try to grab a handful of starbursts. So if you are not in this classroom today, then sorry you will be missing this. But what we're going to do is we're going to use this data to help us to be able to understand a relationship between two variables. Okay? Now, since I don't have an actual class of students when I'm making this video, I cannot collect data from the class. So what I'm going to do is I am just going to create a general sketch of data. So the first thing we need to know when we're making a scatter plot is when we're looking at this, we're going to be relating the hand span, so how far it is from the base of our hand to the tip of our middle finger. Okay, actually in this case we're going to do the distance from the tip of the thumb to the tip of the pinky finger. Okay, I see. All right, so we'll just call that hand span, and we're going to measure that in centimeters. And we're going to relate that to the number of candies that we can pick up. Okay. And so let's see, our hand spans, probably nobody has anything less than 15. So we'll go 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We'll go from like 19 to 25. And then for candies, let's see, 10, 20, 30, and 40. All right, so before we go further onto this, the hand span is going to be what we call the explanatory variable. Sometimes it's known as the independent variable. And we'll talk about how that is the variable that is going to cause you to get a certain number of candies. The candies will be what we call the response variable. So you're using your hand span to determine the number of candies. So the number of candies is going to depend on your hand span, most likely. All right, so let's say I collected this data and I had, oh, by the way, I should number these. And let's say from the class I had someone with a hand span of 17 grab 20 candies, and someone with a hand span of 17 and a half, let's say they can only grab 10. And let's say that two people with a hand span of 19 were able to grab about 12 and 16 candies. And then a hand span of 20 maybe can grab a few more than 20 candies. And I'm just going to keep putting dots here. All right, so now we have our scatter plot made. And so let's describe the relationship displayed in the scatter plot. So when we look here, hopefully you're noticing that as your hand span increases, the question is what's happening to the number of candies? Well, the number of candies that you can grab is going to go up. Okay. So in class, we'll use that applet that you would have put your data in for the class, and we would do the line of best fit. I'm just going to sketch one by hand. So looking here, it looks like I'd probably have a line of best fit about like here. Notice I have 1, 2, 3, 4 dots, kind of 4 to 5 dots below, and I have 1, 2, 3, 4, 4 to 5 dots above. But I went through 2 specific dots. I went through those 2, which will come into play a little bit later. Okay? So I'm just going to use I'm going to use a line of best fit to make a prediction of this line. So we're going to say that it is y hat. By the way, when you see that little arrow above it, that means hat. We're calling that the predicted y, because it's not the actual y value, but it's predicted from our line of best fit. My line here, I'm just going to use what they had here. So we had if this were to continue going, we would have a y-intercept of -45 plus 3.5x. So what this is saying is the number of candies that you'd be able to get is -45 plus 3.5 times your hand span. Okay, so I'm going to write that kind of out to the side here. So predicted candies will equal -45 plus 3.5 times the hand span. So what would be the slope of this line? Well, it'd be 3.5, and what that means is with each additional, with each additional centimeter of hand span, you can grab 3.5 more candies. Okay? And then the y-intercept would be -45. And that means that if the hand span is 0, so if you had no distance between the tip of your thumb and the tip of your pinky, you would be predicted to grab -45 candies. But there's no meaning of this, no contextual meaning in this. Meaning you can't grab -45 candies. Okay? Alright, so some important ideas here. The first thing we need to do is talk about scatter plots. So when we talk about a scatter plot, remember you have your 2 axes, you have your explanatory, I'm not spelling this right, explanatory variable is going to be on the x-axis, and we use that to predict things, so explanatory. And the result is going to be a response. Okay, so we have a response variable, which is the outcome, and it responds to the explanatory. So here's an example of a scatter plot. Alright, for line of best fit, our equation for the line of best fit is going to be y hat equals a plus bx. When we look at this, the y-intercept, that's going to be our a value in this equation. It's when x is equal to 0 in the context of the situation. So when x is 0, it's going to be the predicted y context variable. So if I were to plug in 0 for x and work it out, that would give me the y-intercept. Okay, and then you have slope. Slope is going to be the b value. with each additional x context. So as my x goes up a value, right, the predicted y context variable increases or decreases by whatever the slope is. Okay, so let's check our understanding. Let's do a couple problems here. It says at the end of the semester, a math teacher wonders if attendance has an impact on final exam scores. Here's a scatter plot that shows the number of days absent and the final exam score for 25 students, for a class of 25 students. 25 students. So identify the variable, which variable is explanatory and which is response. So the explanatory variable, when we look at that, that's going to be the number of days absent. And the result from that would be the response variable, and that's going to be the final exam score. So it says describe the relationship as absences increase, final exam score decreases. So now we have the line of best fit is y hat equals 90.39 minus 3.5x. X is the number of days absent, and y is final exam score. So interpret the slope of the line of best fit. So negative 3.5 for each additional absence the predicted final exam score decreases by 3.5 points. Okay? And the y-intercept here, the y-intercept is 90.9. We can interpret that as if 0 days were absent, the predicted score, notice it's predicted, is 90.9. Okay? So that is how we're going to work with line of best fits and scatter plots. And so we will continue our discussion in class and go from there.